starting chapter 2, the first section is solving one-step equations. So, our definition for today, inverse operations. An operation that undoes another operation. Yes. Okay, guys. So inverse operations. You basically want to do the opposite. Okay. Basically want to do the opposite. Opposite of addition is subtraction. Opposite of subtraction is addition. Opposite of multiplication, division. Opposite of division is multiplication. So how do you solve an equation? You solve it by doing the opposite. These are all one-step equations. That's what we're starting with today. Okay. The addition, subtraction, multiplication, division property of equality. Adding, subtracting, or multiplying or dividing each side of an equation by the same non-zero number produces an equivalent equation. What this says is, whenever I have an equal sign, as long as whatever I do to one side of the equation, if I do it the same thing to the other side of the equation, they maintain balance. When you have an equation, it's equal. This side is equal to this side. If I do something to one side only, I'm no longer equal. I must do it to both sides. If you think about it as scales, if I add 2 to one side, I need to add 2 to the other side to maintain my balance. If I don't do it to both sides of the equation, I am no longer in balance. It must be done to both sides of the equation. If I subtract 2 from one side, I need to subtract 2 from the other side, or I'm no longer in balance. It's no longer equal. But I can do whatever I want as long as I do it to both sides of the equation. It's an extremely powerful tool for solving. Do it to one side, do it to the other side, I'm still good. Add to both sides, subtract from both sides, multiply both sides, or divide both sides. I'm always good as long as I do it to both sides of the equation. So, for an example, how do I solve an equation? If I have x plus 4 equals 2, to solve this, I'm going to want to subtract 4, because I want to get the x by itself. And if I do 4 over here, I need to do 4 over there. I have to do it to both sides. If I don't do it to both sides, I don't maintain my balance. If I have x divided by 3 is equal to 2, opposite of division is multiplication, so that means I'm going to multiply by 3. And if I multiply that side by 3, I multiply that side by 3. I have to do it to both sides. If I do not do it to both sides, it doesn't count, it doesn't work. And you have to show all your steps. Okay. Now, problem number 1, solving an equation using subtraction. What is the solution of this? And here's the thing. If you don't show your work, you get 0. You will not get a stamp for today's notes if you don't have the steps. You will not get a stamp for today's classwork if you do not show the steps. When we take the test and you do not show steps, you will get a 0. I don't care if the answer is correct or not. You show the work. I hope that you can solve some of these problems without having to show the steps. I hope that you can figure out that if I have x plus 2 is equal to 3, something plus 2 is 3, you can figure out that something is 1. I hope that you can do that without showing the work. And it would be really nice if you could do that. You still have to show the steps. This is one of the few times I am an absolute stickler about showing the steps and doing it exactly as I do it. I'm doing this for 20 years. I've seen too many students. All I can do in my head, and later they can't because it starts getting more complicated. And they start having problems because they were lazy to begin with, And they end up getting the wrong answers later because it takes more than one step. And they don't know how to show more than one step. Because they haven't been doing the work. They've been trying to get lazy. And when they get lazy, they get wrong answers. And you need to do it exactly as I show you here. Otherwise, you're going to start making mistakes. My job is not just to show you how to do the problem. My job is to show you how to do the problem with the fewest mistakes possible. And I will be a stickler about not showing work. I will be a stickler about not showing work. Okay?
I understand what we need for some of you, you can look at that first problem and know the answer. The first skill test is a multi-step equation where you have to do variables on both sides and how to solve. If you don't show work, then we can't figure out where your mistake is. Okay, so this is just, we understand that it is just one step equations today, but it's important to, when you build on this, that you have all your steps shown.
And you can use your calculator to do the arithmetic. I'm okay with that. You can use your calculator to do the arithmetic, but you have to show the work. The idea is to learn the algebra, problem solving. Okay? So, concept here, the idea here. I have x plus 3 equals 27. I have x plus 3. The idea is I want to get x by itself. I want my x all by itself. Okay? So what I have to do is I have to get rid of what's being done to the x. Okay? Right now, I'm adding 3. So I have to get rid of the plus 3. What's the opposite of adding 3? Subtracting 3. So what do? I subtract 3. I subtract 3 from this. And if I subtract 3 from one side, I need to subtract 3 from the other side to maintain balance. So I subtract 3 here, and subtract 3 here. Notice how I'm doing the problem vertically, working my way down. Draw your line underneath. Okay. The plus 3 and the minus 3 cancel each other out. What am I left with? I'm left with x. My equals just comes down. And then on the other side, I have 27 minus 3. Okay, 27 minus 3 is 24. X equals 24. What not to do? What not to do? What I see students do that is wrong. I will see students, you have the original problem. X plus 3 equals 27. I'm going to go, I subtract 3, which means I get 24. That's wrong. That's not the answer. That's not how you do the work. You did not subtract 3 from both sides. What you just did was say, hey, x plus 3 is equal to 24. It's wrong. You do not say x is equal to 24. You do not show me that x is equal to 24. You just changed the problem from being x plus 3 equals 27 to x plus 3 equals 24, which is not the answer. That's the most common mistake students make because they work horizontally. They work across, I subtract 3, which gives me this. No, that's not what you do. You need to subtract 3 from both sides of the equation. You need to work both sides of the equation. This is very, very bad. I will make you redo those problems. Okay, because you're not getting the right answer. And if you say that, well, that means x equals 24, no, it doesn't. The problem you gave me, x equals 21. Because that's what you did. You changed the problem. Okay. Any questions about what I want you to do? I'm trying to be perfectly clear. Yes, I'm being a little stern and harsh, but I want to have no misconceptions about what my desires from you are. I want to be perfectly clear what my expectations are. Okay. Problem number 2, solving an equation using addition. So once again, I'm going to get x by itself. I have x minus 4. What's the opposite of subtracting 4? Addition. Adding. And what do I want to add? I want to add 4 to both sides. Add 4. Add 4. My plus 4 and my minus 4 cancel each other out. And I get x equals, because my equal sign just comes straight down. And then 12 plus 4 is 16. And once again, you can use a calculator for this. If you're having a brain spasm and can't remember how to do 12 plus 4, you can use your calculator. 12 plus 4. I'm okay with that. I'm okay with that. Problem number 3. Negative 2m equals 36. When I have negative 2m, what does that mean I'm doing to the m? What's being done? Not what do I want to do, what's being done to the m? What? Yeah, that's what I want to do, but what's being done to it here? What does negative 2m mean when I have negative 2m?
It's being multiplied.
Being multiplied by what? By negative 2. Watch your negatives and positives. Okay. So I want to get m by itself. What's the opposite of multiplying by negative 2? Divide by negative 2. So that's what I do. I divide both sides by negative 2. Okay. Negative 2 times n, the opposite of multiplication is division. Divide both sides by negative 2. The negative 2's cancel each other out. I'm left with m on the left equals, and then I take negative 36 and divide it by negative 2. Once again, if you need to use your calculator to do this, use your calculator to do this. Okay, if you're not sure or you're nervous about it, feel free. So half of 36 is 18, so I get negative 18. Okay, did half the answer. Questions? Okay, problem number 4. Solving an equation using multiplication. So on the left-hand side of my equal sign, what do I have going on there? X what? What am I doing to the x? Yeah, x divided by 4. That means x divided by 4. What's the opposite of division? Multiplication. So what am I going to multiply both sides by? 4. Multiply both sides by 4. So I multiply this side times 4, and I multiply that side times 4. You must do it to both sides. 4. There. Better. Show the steps. Show the work. I need to see this. Your 4's cancel each other. You're left with x equals. The equal sign just comes down. And then you do negative 9 times 4, which is going to be negative 36. Ladies, questions? Okay, problem number 5. This is probably the most difficult type of problem you will have today. Now, there are 2 ways of thinking about how to do this problem. There's the hard way, then there's the easy way. What do I want to do? I want to get m by itself, right? How many m's do I want? When I have m by itself, how many m's do I have there? I have 1 m, right? That's what I want. I want 1 m. I want 1 m equals some number. Okay, that's my goal. So what I want to do is I want to get rid of the fraction out in front. Okay, now I talked about this a few weeks ago when we were started working with fractions. And what do we multiply by to get 1? We multiply by the reciprocal. A number times its reciprocal will give me 1. So I want to multiply by the reciprocal of 4/5. What do I do to find the reciprocal? I flip it over. So that means I multiply both sides by 5/4. Multiply by the reciprocal. And if I multiply one side by 5/4, what do I have to do to the other side? Multiply by 5/4. Yep, you got fractions. You don't like fractions? Fine. Pull your calculator out. We showed you how to use fractions on your calculator. I'm okay with that. Please. Okay, I don't want you to get stuck on the arithmetic. I want you to understand the algebra. The 4 and the 5 cancel each other out, and I get M. And then I do 28 times 5/4. And if I do that, and let's see, 4 goes into there once, goes in here 7 times. I get 35. And like I said, use your calculator. 28 times 5/4. You get 35. I'm okay with using your calculator for this. Because the algebra, you're still doing the algebra. The calculator is just helping you with arithmetic. Okay. Question? Okay, now we get to the fun one. Oh, wait. Why do you multiply by the reciprocal in the above problem? Here's why. To get 1. Because that's the only reason you multiply by a reciprocal, to make it 1. To get 1. That's why you multiply by a reciprocal, to get 1. One of those things. That's what reciprocals do. Okay, problem number 6. Using a one-step equation as a model. Toucans and macaws are tropical birds. The length of an average toucan is about 2/3 the length of an average macaw. Toucans are about 24 inches long. First, write an equation as a model. Okay. Stop talking. Other people are trying to pay attention even if you're not. Okay. So first write an equation as a model. So I'm comparing macaws and toucans. Okay. So the idea is the length of a macaw, the length of a toucan is 2/3 the length of a macaw. So toucan, and I'm going to use L. They actually have an L there. It's hard to read. That's actually supposed to be an L for that. Okay. So toucans and macaws are tropical birds. So that means 2/3 the length of a macaw is the length of a toucan. Toucans are 2/3 the length of a macaw. Okay. Now, so I have my model. It says, then I have toucans are about 24 inches long. And what I want to do is find the average length of a macaw. Where does the 24 go in here? For the T, I replace the T with 24. So I have 2/3 L is equal to 24. And I solve that. How do I solve that? What do I do? 3/2. 3/2. Multiply by the reciprocal, which is 3/2. So 3/2 times 3/2. These two cancel. And the average length of a macaw is 36 inches. That's how you do that. Questions? Once again, you must show your work. You must show every step of your work. No skipping work. Sure, let's do that. Yeah, I'll do that. So do we want to hand it out first? Have them do it along with me?
Yeah.
Okay. So the last 4 problems are combining like terms. Do you see an equal sign in any of those, the last 4 problems? No, there's no equal sign. So you will not get x equals some number. No equal sign, no solving. Okay, be perfectly clear. If you do not see an equal sign, there is no solving of the problem. There is no solving. However, you can simplify. And you can write this something neater. What you want to do is combine like terms. And like terms are things that where the variables are exactly the same. The variable portion is the same. And this one is fairly simple. I have 2 sets of two types of terms here. I look at my first one, I have 2x. And I go through, do I have any other x's? I have 4x and 6x. Those are like terms. They all have an x. And then what do? I combine those together. How many x's do I have? Okay. If I have 2 apples in this hand and 4 apples in this hand, and then I've got 6 in the bag in the middle, and I put them all together in the bag, how many apples do I have all together? 12. How many x's do I have all together? I've got 12. The only thing that changes is how many of them I have. They do not become squared. They do not do anything like that. Nothing happens. It's how many x's do I have? I have 2 plus 4 is 6. Plus 6 more gives me 12. Okay, I did not change the apples. I just have apples. The x's don't change. When I'm adding and subtracting, they don't change. And then I have my other like term. What do I have left? I have a 7 and I have a 1. No x's. I add those together. What's 7 plus 1? 8. There's my answer. 12x plus 8. Okay. Do not add them together. They are not like terms. These are apples. These are bananas. We are not making fruit salad. Okay, we are not making fruit salad. I do not like my apples and bananas mixed up together. I like to eat apples. I like to eat bananas. I do not like to eat apples and bananas at the same time. We keep the apples and the bananas separate from each other. We do not combine them up. These are not like terms. This has an X on it. This does not have an X on it. They are not like terms. I cannot combine them up. Okay, so you will not end up with a single thing at the end. Okay, questions? Okay, get to work. Remember, show all your steps.